This is going to be the most difficult proof of series of E. Okay, in this video we are going to prove that the sum from n equals to 0 to infinity 1 by n factorial is E in the most difficult way. Okay, so let us proceed. And I will just give you idea on why the steps that I'm doing will work, and not how did I get the idea to do that step. Okay. So my first step will be I will write 1 plus summation from n equals to 0 to infinity 1 over n plus 1 factorial. So you can already see the reason for it. Since I'm starting from 1 factorial, the 0 factorial is over here. Okay, after this uh, I'll make a good manipulation as 1 plus summation from n equals 0 to infinity 1 by n factorial times 1 by n plus 1. Okay, and after this 1 plus summation from n equals to 0 to infinity 1 by n factorial times 1 by 2 times 1 by n plus 1 by 2. So this is my next step, and again the next step after this will be 1 plus summation from n equals to 0 to infinity 1 by n factorial dot 1 by 2 dot, and then over here I have gamma n plus 1 by 2 plus 1, that is factorial of this number, and over here gamma n plus 1 by 2, which is the factorial of a number 1 less than this, and over here I can write gamma 1. Yeah, so this is just equal to this original expression. And now you may notice something. You can notice that n equals to 0 to infinity 1 plus, you can notice that summation from n equals to 0 to infinity 1 by n factorial 1 by 2, and this is just beta function of n plus 1 by 2 and 1. Yeah, and then 1 plus we can write that beta function in terms of integral of sines and cosines. We will use that. This will be integral from 0 to infinity. Yeah, and also I need to remove this 1 by 2 over here now. Integral from 0 to infinity sine to the power 2 times this value minus 1, which is n plus 1. This is my 2 times this value minus 2, which is n, sine to the power n theta, and cos to the power 2 minus 1, that 1 theta d theta. Okay, so now we have this, and now we can understand the integral in summation. 1 plus integral from 0 to infinity summation from n equals to 0 to infinity, yeah, sine to the power n theta by n factorial times cos theta d theta. Now cos theta is just constant for this sum, so I can take that out. I can take cos theta out, and the remaining thing, it's just summation from t equals to 0 to infinity x to the power t by t factorial, which is e to the power t. So this is e to the power sine theta d theta. And now I guess you can easily integrate this function by u substitution. you can just yeah, is the okay, I made a mistake over here. It's actually from 0 to pi by 2 for the case of sine and cosine, and for x and 1 minus x only, that's 0 to infinity. So this is 0 to pi by 2, this is 0 to pi by 2. Now we can let sin theta as u. We get 0 to 1 e to the power u and cos theta as du. Now we can easily integrate this. Yeah, it's 1 plus e to the power u from 0 to 1. So that's 1 plus e to the power 1 is e to the power 0 is 1. So we get 1 as our answer. Now we have derived that summation from n equals 0 to infinity 1 by n factorial is equals to e. Yes, we have done that. So we have finally proved that summation from n equals to 0 to infinity 1 by n factorial is equals to e using integral beta gamma function. I hope you enjoyed the proof. Thanks for watching, and do share with your friends. I look forward to seeing you in the next video.